In this unit we will be looking at Scratch, which is an object-oriented programming language using blocks. You might have used Scratch before in primary school, but in Year 7 we're going to develop your knowledge of Scratch by creating 2 games. The first game will be a catching style game where you have to move your object around to catch another object, and the second game that you'll eventually create will be your own version of Flappy Bird. So before we move forward with Scratch programming, let's have a little recall of our knowledge, and you need to be able to answer these questions in your ePortfolio. So what does SSL stand for? You can also, from this unit, explain what is an algorithm. Although we've not covered it in this unit, we have covered that previously in a different topic. And you might also recall what a QR code is. You need to explain that. And from the start of the year, you'll need to be able to remember what a phishing email is. Now, these answers will be in your knowledge organizer if you've not already remembered the facts. If you can remember the facts, then brilliant. You'll need to pause the video and answer these questions. Talking about our knowledge organizer, here is the knowledge organizer for our Scratch unit. You've got a copy of your knowledge organizer. This information will be in there. And these are the keywords and understanding that you need to know from this unit. Now today we're going to be talking about this graph here, these coordinates, these Cartesian coordinates. So this will be what part of today's lesson is. So this refers to here, and it's also referring to Cartesian coordinates, the x-axis and the y-axis. So this is the information you need from today's lesson. So I've already said we're going to understand Cartesian coordinates, the x-axis and the y-axis. You might have already covered this in maths, in which case if you have, that is absolutely brilliant. It's recalling knowledge from other subjects. So thinking about Cartesian coordinates, what we need to look at is what they are and their positions on a computer game. So let's just bring up our visualizer. What we should be able to see here, if I draw some Cartesian coordinates, I'm just going to draw an x-axis and a y-axis. So the one that goes horizontally is my x-axis, so I can label that. And the one that goes vertically up and down is my y-axis. And again, I could just label that y-axis. So what we've got here is coordinates on our screen, and this place right in the middle is known as 0, 0. And I can just label up my x-axis as I go. I'm only going to go to 10. So there's my x-axis. So if I move to position 1, it's moving along this line, and this is what we've got here. So my x-axis, if I go backwards, remember we've got 0 right in the middle. So this here will therefore be -1, -2, -3, -4, and so on. So that's my x-axis, 0 in the middle, moving up and moving down. The axis moving from up and down, from top to bottom, is my y-axis, and this works in exactly the same way. So going up, we've got a 1, a 2, a 3, a 4, and 5, and that carries on all the way up. And going down, we have a -1, -2, -3, -4, -5, -6, and obviously that carries on as well. So my x-axis is the horizontal axis, and my y-axis is my vertical axis going up and down. So we start with 0, 0 right in the middle, and we always read our x-axis first. So if I'm looking at going to point 7, 1, go to 7 and then 1 up, so that will be just there. That'll be 7, 1. And then I can move my x-axis by 1, which means I will move to that place there. So that's our coordinates when we're referring to them as Cartesian coordinates. What you need to do is add that information into your ePortfolio. It'll be useful for you to draw that chart to show that information, Cartesian coordinates, and explain what the X and the Y axis is. Now that we have an understanding of Cartesian coordinates, we need to get underway with Scratch and actually start making the first bits of our game. So there's a couple ways you can use Scratch, and what I'm going to do here is just using Google. I'm going to search for Scratch, and all I need to do is click the little microphone and say the word Scratch. Scratch. And it's found the website here. So scratch.mit.edu. Obviously you can just search for Scratch ordinarily, but I like the way the microphone works. So scratch.mit.edu. This file here, MIT, or file extension of edu, is education, and MIT is Massachusetts Institute of Technology. And this is Scratch here. Now we can use Scratch on the web. We don't have to download the game, but if we did want to download Scratch, we can download that. And again, if you go to Google and just put in download Scratch, download Scratch, you do have the offline editor that you can download for your different devices here. But you don't need to. It's just if you wish to download Scratch and install it on your own machine. I'm quite happy with the normal version of Scratch on the web. So once we've opened up Scratch on the web, we can just click Create. And this opens up a brand new version of Scratch that we can actually work on. It takes a second or two to load up. Now there is a section here with tutorials that you can read through, play these little tutorials, or you can just close this because I'm going to explain these bits to you. Now when you're making your Scratch game, I have seen lots of people use Scratch the Cat here, but I want you to personalize this game and make it your own. So what I'm going to ask you to do is to remove Scratch here. So there's a little bin here on Scratch. You can just click that and it takes Scratch away. And you're going to create your own sprite now, your own item that you're going to create as your main item in the game that you're going to move around to catch other objects. Now I'm just going to take my camera off a second. So down in this bottom right corner, I'm just going to have to lift it up a bit. Down in this bottom right corner, you'll be able to see this Create New Sprite button. So you're going to have to click the Create New Sprite. And if I just go back a stage, there were different versions in there. You can upload your own image if you wish. You can just have a random one appear. You can paint your own, or you can choose a sprite from what's already in Scratch. Ideally, I'd like you to paint your own. So let's just put my camera back on. So you're going to paint your own, and you can be as creative as you like in here. All I'm going to do for starters is just draw a circle as my sprite. I've used a circle here. You can add text, fill color, drawing, lines, and so on. But I want you to be creative and make your own sprite. You can see that my sprite is now here on the right. This is under costumes, and I can just rename my sprite. Click on code. In the top bit here where it says sprite 1, I'm just going to call mine ball, but you can call yours whatever you wish. So there is my sprite. It's on my stage, and at the moment it does nothing until I give it some instructions. So what I'm going to click on is control, and I'm now looking for, so I didn't mean control, I meant event, when space key is pressed. When space key is pressed, so I've just dragged this block into my coding area. I'm on the code section in the top up here. I'm not on costume, I'm not editing anymore. I've gone back to code, and I've dragged in from event when space key pressed. And now I need to go to my motion. And what I'm looking to do is change X by 10. So this is referring to the Cartesian coordinates we've already learnt about. So now when I press the space key, you'll see that my ball moved along the x-axis 10 spaces. It's actually 10 pixels. So there we go, another space and another space. Now I don't want to use the space key to control my ball. What I want to use is the right arrow. So where it says where space key pressed on the space bit, it's a drop down box. I can just change that to right arrow. Now when I press space key, nothing's happening. But if I press my right arrow, my ball is moving across the screen 10 pixels. Now I need it to go backwards because keep pressing right, it disappears off the edge of the screen. So I want it to go the other way. And what I can do is I can duplicate this code by right clicking on it, duplicate, and just putting it there. And I can change my right arrow to left arrow. Now I now need to change my x-axis. Remember, we're still going horizontally, but I'm going backwards with the left arrow, so I need to make this a -10. So now when I click my left arrow on my keyboard, my ball will go back left. It's going -10 pixels every time I press the key. So I can move forward and backwards as I wish with my keyboard. At the moment, my ball will not go up or down. I'm pressing the up and down buttons on my keyboard and nothing is happening. So I need to add a new bit of code in for this. And again, that will be under event. And I'm looking for when space key pressed. And I'm just going to drag when space key pressed. And I'm going to change that to up arrow. Now thinking back to coordinates, Cartesian coordinates, we've worried about the x-axis, we've got that sorted. We're now going up and down, so we need to be thinking about a different axis, and the up and down axis, vertical axis, is the y-axis. So I go to motion and I'm looking for change y by 10. Now when I press my y key, it's going up. I'm not going to put the answer in here to get the ball to go down. I'm going to want you to do that yourself. And the other thing you might want to do is you might not want your arrows to move 10 pixels each time. So you might want to change the value from 10 to something else. And this is the next stage that I'd like you to complete and then show evidence in your e-portfolio. So you'll need to screen print this. And remember, there's a couple of ways you can screen print. If you've got a Windows 10 machine, you can press Shift, the Windows key, and S at the same time. And what will then happen is you can draw a box around the section that you want to copy, just like this. That will copy that. I'm not sure if that showed on the video. Copy that, and then you go into your ePortfolio and Control V for paste, or paste it into your ePortfolio. Or you could take a screenshot of Alt and press print screen on your keyboard. So hold down Alt, press print screen. That will take a screenshot of your window, and then you can paste that into your ePortfolio. So we're looking for evidence in your ePortfolio of your Scratch game. So a reminder that you can get to that from scratch.mit.edu if you Google that, and then include the evidence of your blocks of code and explain what your blocks of code actually do. So the next thing you need to do is save your Scratch project. You don't want to lose any of the work that you've produced, and you're going to be building on this from next week and the following week to create a more impressive game. So I'm just going to show you how you save your Scratch work. And here's mine at the moment. I'm just going to end that. So what we've now got is the game here. And remember, I'm running this in a web browser. So when I click File, Save to your computer, it's going to download this Scratch file to your download file on your web browser. And here it is, my Scratch project. So it's downloaded it. I'm using Google Chrome here. It's downloaded it to the bottom. Using different web browsers, it might download it to somewhere else. So all I now need to do in Google Chrome is drag this file here just to my desktop. So I can download that, and it's saved my Scratch project. And what I can actually do is right click on this, and I can rename my Scratch project movements. So that was where I've used the X and Y axis to move my ball. So when I come to do this next week, and open up Scratch again, all I need to do is load from my computer. I can choose the file that I want to load and it'll bring that work back into Scratch. So although I've used it on the web, used Scratch on the web, I've downloaded my file, kept it on my computer, and then I can reload it back into Scratch when I need it the following lesson.